What the fuck is this shit? Okay, let's reimagine this, and then we get the equations for R total. How do you want to reimagine this? So there are a lot of tutorials on YouTube, so you can just base off of that. But I'll show you this. So first what you want to do is you want to lay out all the exterior resistors into one line. So it's gonna look like this. So that's your R1, this is your R3, R8, R10, R7, R5. So yeah, it wraps around, right? Let's label R1, R3, R8, R10, R7, and R5. So now we're just gonna be looking at what's inside of this. So we're gonna be starting to note our parallel nodes now. We look at R2. This is R2. And you see that R2 is at the tail of R1. So you do like this. This is R2. And you can write R2. You can this is you can show R2 like this. That's R2. And then it is connected to the tail. I mean, not the like this part of R5. Like, yeah, the tail of R5. Because if you think about the current flows this way, comes back this way, or whatever. Yeah. Anyway, this makes sense. So you can do like this, and that will still make sense. That will still be true. So now that we're done with R2, let's look at the next one. R4. R4 is at the tail of R3. It's at the tail of R3, and it's connected to R5 again, right? It's connected at this point, same as R2. And we can just do the same. We can just do this. You can just do like similar to what we did for R2. As long as it's connected to R5, right? So this is your R4. Next, we have here R6. R6 is located between R3 and R8. So yeah, same as R4. So what you're gonna do is you're just gonna do the same thing. This is your R6. That's 6, right? Yeah, that's 6. R6, and it's connected between R5 and R7. So that'll look like this. Yeah. And then lastly we have, what are we missing? R9. Yeah, R9. Since we don't have space anymore. So R9 is at the start of R8, right? Start of R8 until the tail of R10. So we can just represent it like this. We go like this, and go like this. And this is our R9. So this is the full expanded form. Now, like what we always do, we can write down our equations. Wait, let me just, this is R6. So, wait, I did something wrong. What did I do wrong? R9, right? R9, okay, yeah, I did something wrong. My bad, guys. R9 is, remember, why did I write it there? It's at the tail of R10. Because you look at the, you know, like right there. This one. Okay, now we write our equations. So remember when you're looking at a circuit, what you want to do is you want to find which is series first. Yeah, and then you build off that. Let's look at what is series. If you look at what is series here, you can see that it's just it's just R8 and R10. Let me just, okay, R8 and R10. So you can say that R8 10 is equal to R8 plus R10. Again, we're just writing equations, we're not actually solving for it. Next, so now we have R8 and R10. You can see that R8 and R10 is parallel to R9. So you can say that R8, 10, 9 is equal to 1 over R8, 10 plus 1 over R9. Again, there's a different formula. There's another formula for parallel resistance circuits, but you can this is like easier to understand. And then okay, by the way, how do we get that? So remember, this is R810 and R810 is parallel to this. Okay, so it gets confusing like this, right? Because there's a lot going on. There's a lot of stuff going on. What do we do next? So you can like rewrite this. So it's like this whole part, because we have this whole part now. It's now it's now in series with R7. Yeah, I mean, you can just look at it. So we have here R8, 10, 9, 7. Also, if you get asked why I'm not like doing it by order, it's because like if you do like this, like I don't like that. Because if you do it doesn't matter. If you do like this, you're able to retrack your steps. You're able to retrack how you got 9, how you got 7. So yeah, basically like that. Okay. R8, 10. Wait, let me fix that. R8, 10, 9 plus R7. So now we have this whole thing. This whole thing is now in parallel to R6. So let's do that. Oops. R8, 10, 9, 7, 6 is equal to 1 over R8. Oops. Let me just do R8, 10, 9, 7 plus 1 over R6 raised to negative 1. So yeah, so I guess it's better if you like, let me see how do you, oh, I actually don't know how to do that. I'm gonna mark that. I'm just doing like this. So we do like this, so we have this, right? And since we opened this up, like that's how I understand it, it's in series with R5 now. Because we like, that's what's next. That you open it up. If that makes sense. I know, it's kind of confusing. But yeah. 6, 5. We go to R8. Why did it change? R8, 10, 9, 7, 6 plus R5. So now you have this whole thing, and then it's in parallel with R4. Alright, so let's do this again. R8, 10, 9, 7, 6, 5, 4 equals to, yeah, it gets kind of tiring. R8, 10, 9, 7, 6, 5 plus 1 over R4 is a negative 1. So now we open this up. We open this up, and now it's in series with R3. I mean, I don't know if you follow, but yeah. So, alright, 8, 10, 9, 7, 6, 5, 4, 3 equals to R 8, 10, 9, 7, 6, 5, 4, plus R3. let me fix that. Plus R3. So now you have all of that. If you look at it, now you just have you just have this, right? Oh yeah. There's this, or this R1, I forgot. So yeah, I mean, I guess you see what I'm seeing. We have, oops, R 8, 10, 9, 7, 6, 5, 4, 3, 2 is equal to 1 over R 8, 10, 9, 7, 6, 5, 4, 3 plus 1 over R2 raised to negative 1. And then this whole thing, yeah, this is in series, so R total is equal to R 8, 10, 9, 7, 6, 5, 4, 3, 2 plus R1. I don't recommend this, because you're gonna be, if you follow like what I usually do, you're gonna be making for your current as well, and you're gonna be making for your voltage. I mean, if you have the time, I guess, but like maybe in this situation, it's just better to just go manually, like look at the circuit, keep going back to the circuit. So yeah. Anyway, that's the equation for our total. Thank you for listening. I'm tired.